Thank you so much. Thank you for the intro, and I'm honored to be here, and I really appreciate you having me participate in this awesome event. So, yeah, like he mentioned, he gave me a quick intro, but I'm going to go a little bit more into that. But welcome to my talk. Today, I'm going to be talking about turning the cloud inside out. We're going to talk about how to create a cloud programming interface with GraphQL. We're going to be talking about a bunch of different things, and I hope you are going to be interested in some of the stuff I'm talking about. It's my first time ever giving this talk, and I'm really excited about the ideas that I'm going to be presenting here. So my name is Nader Dabit. I'm a senior developer advocate at AWS. I've been here for a little over 3 years, but by trade, I'm actually a front-end web and mobile developer. So before I got into AWS, I was actually working more on the front end. And for 5 or 6 years, I was a software engineer. Then for a year and a half, I went into consulting. I created my own company, and I was doing training for companies like Amazon, like Microsoft, Warner Brothers, a bunch of big companies, and medium to small companies as well, just kind of showing them how to build cross-platform applications using React Native and JavaScript. So I was very heavily into that front-end ecosystem and that mobile ecosystem before joining AWS. And a lot of times when people think of AWS, they think of back-end developers, they think of infrastructure, they think of servers, and they think of DevOps and things like that. But the team that I work on is actually kind of unique within AWS. Everything that we're working on is very client-side focused. So we maintain a lot of the JavaScript SDKs for things like the front-end developers and mobile developers, what they're using to build their apps. And everything that we do is really focused on helping front-end developers and helping developers new to the cloud kind of get up and running and kind of trying to lower that barrier to entry. I'm also a teacher, so I really enjoy my role as a developer advocate because I get to teach, I get to help people learn. And before I did any of this, I even started meetups and was running meetups, and even started and ran a coding school in my hometown where I live in Mississippi, where there isn't a ton of technology and things like that, opportunities going around. And then finally, I'm an author. I've written a couple of books. One of those is React Native in Action, and the other is Full Stack Serverless from O'Reilly Publications. It kind of mirrors some of the stuff we're talking about here today. So if you're interested in what I'm saying here, and you might be interested in learning more, check out my book. So this talk is kind of broken up into 4 main parts. We're going to talk about an introduction to GraphQL. Now, if you've used GraphQL, you might have heard a lot of these ideas before, but hopefully that the spin that I put on some of this stuff, or maybe the ideas that I share are maybe slightly different than what you've heard in the past, and maybe you'll learn a little something even if you're already familiar with GraphQL. Then I'm going to talk about the philosophy of the ideas that I'm trying to share here. Then we're going to look at how to implement this, both in some example diagrams and overview, as well as code. So at the end of this talk, I'm going to actually be building something completely from scratch, from the ground up, and then deploying that using the ideas that I'm talking about here today. So let's talk about GraphQL. Now, if I was at a regular in-person conference, I would probably ask people to raise their hands, who has used GraphQL, in what capacity, and I would have a better idea around, who has used it or who hasn't. But regardless of the answer to that, GraphQL is rapidly growing in popularity, and it's rapidly growing in adoption. Now, GraphQL is an open source data query and manipulation language for APIs and runtimes for fulfilling queries with existing data. GraphQL is a specification also. So when you implement GraphQL, you're kind of going by a specification, but there is no single way to do this. And therefore, you see different implementations across different companies and across different services. But once the implementation is complete, you can consume a GraphQL using the existing skill set that you learned anywhere else. So the GraphQL API is always going to depend on the data graph, and you as a consumer of the API can kind of understand what's going on once you've learned GraphQL, regardless of the implementation or the implementation details. So what are some of the benefits of GraphQL? These are the most popular ones that I hear, and also the most important ones to me. First of all, you get type checking built in. You get validation and type checking out of the box. This is part of how GraphQL works. And as a front-end developer, we're seeing a lot more adoption of things like TypeScript. And when you're working with a TypeScript front-end, GraphQL works really well, and it fundamentally goes really well with the ideas that TypeScript presents on the back end. So when you're working with TypeScript and you're working with GraphQL, it kind of makes for a really, really nice developer experience. GraphQL also has real-time and real-time baked into the actual implementation of how you typically are going to be building this. So when you're working with a REST API and you want to implement some type of real-time functionality, you might need to kind of look around and see what other people are doing, or maybe take some of the experiences that you've had in the past. And maybe you're doing something with WebSockets, maybe you're doing something with server-side events, you might even be doing something with polling. But because GraphQL has subscriptions baked into the specification, whenever you build out a GraphQL API, you can fairly easily implement subscriptions using the specification, and they're consistent across all the APIs. So they're always dependent on mutations, which we're going to be looking at. But most GraphQL APIs have real-time baked in. You can also work with a single API call and also a single API endpoint with a GraphQL API. So for instance, let's say I have an onload function in my app, and when my app loads, I need to fetch a user profile for the user. I might need to fetch a list of products. And then maybe for our example later, we're going to be maybe fetching a wish list for a e-commerce API or an e-commerce app. Now, with a traditional REST API or a traditional REST API gateway, you might be making multiple API requests to get all this data. And then you might be reusing those same queries in different parts of your app. But with GraphQL, you can actually send all of the queries that you would like in a single request. And we're going to look a little bit deeper into that later and what that looks like. Query efficiency is also a big part of this, and also the ability to decide which data that you want coming back from your queries. So with the proliferation of multiple platforms built within a single API, so for instance, we're seeing a lot of companies, and I have experienced in this in my actual consulting career. We have a single API, but we want to consume this from a web application, maybe a desktop application, and then we also want to consume this from some type of tablet application. When you build your API with GraphQL, you can more easily decide which data that you want back depending on the view without having to write any more backend code at all. So once you've implemented your graph, once you've implemented your queries, regardless of the data that is part of the type that you're looking for, the data that you want is what comes back. So you can query for a single field on a type, or you can query for all of the fields on the type. It doesn't matter what you do. You can mix and match these in almost infinite ways without, again, having to write any more code. And this prevents both overfetching and underfetching. So the overfetching might be, I need to fetch, this profile data, but I'll only need the user's ID and maybe their username. When we fetch this data from a REST API, we might be getting back a larger payload than we actually need. So we might be also getting their address and other information. And therefore, we're kind of adding additional latency for no reason. So with GraphQL, we can just say, oh, we only want the ID and we only want the user's name. And then everything else we don't really want to worry about. And then also it prevents underfetching. So for instance, let's say I need to call three API calls for the data set that I want. With HTTP, REST, you're typically needing to make 3 separate requests. With GraphQL, you can bundle those all into a single request. GraphQL has automatic API documentation and auto-generating API documentation baked in. So this is called schema introspection. And introspection is the ability to query which resources are available on the current API schema. And this is, again, part of the specification. And given the API introspection, we can see that the queries, types, fields, and directives that it supports. And this is the same across all GraphQL APIs. And we're going to be taking a look at what this looks like in just a moment. In addition to API documentation, it also allows a much easier API evolution. So evolving an API usually means having to keep the old version around until teams make the transition to the new version. With REST, it's common to offer multiple API versions then. But with GraphQL, it eliminates the need for versioning by deprecating API fields, APIs on a field level. Aging fields can be later removed from the schema without impacting the existing operations. GraphQL enables that by creating a uniform API across the entire application that isn't limited by a specific storage engine. Then you also get API consistency. So for instance, once I learn how to work with GraphQL, every single GraphQL API, not only in my organization, but also in the entire ecosystem or within any job that I might have in the future, will seem very familiar with to me. So I'll be able to jump between different graphs and be able to get up and running really quickly, because all GraphQL APIs are essentially the same from the outside looking in. And I've sent this tweet out because I think this is a really interesting idea. Learn once, create, read, update, delete, and subscribe anywhere. I'm really a big fan of learning a single technology that allows me to do the most without having to learn anything else. And I think GraphQL is a perfect candidate for that philosophy. And also, so for instance, something else that might fall into this same category is something like React. You learn React, you can build web apps, you can build mobile apps, you can build desktop apps, you can build pretty much all types of different applications, but you're only really fundamentally learning one programming paradigm, and you're able to apply that across a lot of different areas. So efficiency around what you're learning. And then the final thing, and this is really the core of the idea that I'm going to be presenting here with the cloud, is the idea that GraphQL is a great fit for complex systems and microservices. So by integrating multiple systems behind its API, GraphQL unifies them and hides their complexity typically. The GraphQL server is then responsible for fetching the data from the existing systems and packaging it up in the GraphQL response format. This is particularly relevant for legacy infrastructures or third-party APIs that have expanded over the years and now present a maintenance burden. So now that we've kind of gone over some of the benefits of GraphQL, let's talk about what a GraphQL API looks like. There's typically three main parts of a GraphQL API. You have your schema, you have your resolvers, and you have your data sources. The schema defines your actual data, and it's the graph that you're kind of looking at to understand what's going on. The resolvers are the function or the business logic that maps the GraphQL operations to the data source. And then data sources are essentially microservices and databases that are where the data is going to be coming from your operations. So to understand this better, let's take a look at a GraphQL schema. When we first look at the schema, we have a very good understanding around what type of data that we're working with here. So I can come in here and I can look and I can understand automatically that we have a few different types. We have a transaction type, we have a user type, and we have a product type. I can also see the fields that are available and whether or not they're required just by kind of taking a quick glance at this API. And then I can also look and see what operations are available. And I think this is, to me, the most important part of a GraphQL API. This is where I go first when I'm looking at a new API. I look at the mutations, I look at the queries, and I look at the subscriptions, because this defines what type of data that is going to be resolved from our data source. So here we can see that there are only two main operations from our data source, one for creating a transaction and one for querying. So the schema is kind of what you would go look at and get an idea of what's going on with the API, but it's also describing the data and the operations that are available for the API. The next thing is the resolvers. So the resolvers are functions or handlers for business logic between schema operations and data sources. So let's take another look at a query. When I see this query, I kind of have a really good understanding about what's happening here. I have a list transactions operations that's going to return an array of transactions, and this array is required. So what actually happens when this resolver gets executed? Well, all we're essentially doing is calling some function somewhere. So we're going to be executing a function. That function is going to go do something with the data source, and then it's going to return our array of transactions. Now, looking at this GraphQL API, again, it's very, very easy to kind of look at it and understand what's happening here. We have a query returning an array, and we can go look at the data structure for that array just by viewing the transaction type. So we talked about schema, we talked about resolvers. Let's now look at data sources. Well, data sources don't have to be databases. They can be databases, microservice, serverless functions, or even HTTP endpoints. And I think in the context of building a microservice architecture, understanding that it doesn't have to actually be a database for a data source is really, really important. So that's my overview of GraphQL. Let's now talk about the adoption of GraphQL and how that's coming along. Well, GraphQL is rapidly being adopted by the entire industry. Now, AWS, we use GraphQL. A lot of other big companies, Netflix, Twitter, Uber, Peloton, Reddit, Twilio, GitLab, Twitch, GitHub, PayPal, Shopify. I could go on and on. Of course, Facebook uses it. They're the ones that kind of came up with it, right? So a lot of the ecosystem is thriving. A lot of other interesting information is, to me, around developer sentiment. So if you look at the latest results from the State of JavaScript survey, the number one rated data layer is GraphQL, and it's consistently been the number one rated data layer across the last few years. You can also look deeper into the sentiment and see that the negative sentiment is very low and the positive sentiment is very high, with a large number of people that have yet even try it. And the number of people that have tried it and have a positive sentiment of it is also much higher than basically any other option out there. And to me, that means that we're in a good place, and hopefully we'll even get into a better place. The ecosystem is thriving, the developer community is thriving. But the general idea that I kind of want to really get across here, and this is going to be mainly in the context of a cloud, but we're going to take a step back first and look at the idea of GraphQL as an API gateway. Now, there are a few different ways that I'm going to kind of talk about implementing GraphQL as an API gateway today, but the four that I'm going to be focusing on in this talk are going to be in the context of microservices, the context of third-party APIs, the context of blockchain and Ethereum, and then we're going to deep dive on cloud. And I think that kind of talking about them in all of these different ways will hopefully get my point across a little better. So let's first take a look at microservices. And there are a couple of different ways you might go about implementing a microservice architecture. First of all, you might have a microservice architecture that has a bunch of different endpoints, and these endpoints are very inconsistent, and the APIs around these endpoints are also inconsistent. Now, this is not very fun as a front-end developer or as a developer consuming these APIs, because they're typically going to be implemented different, and I'm not going to have a cohesive understanding of any consistency across these APIs. Another popular way of implementing a microservice architecture is using some type of API gateway. Now, in the REST world, this would just mean you have some type of REST endpoint, or you have some consistency across your REST endpoints where you're working with some type of main entry point with different endpoints from that endpoint. So for instance, we might have our HTTP endpoint /users /developers /people, whatever. And these endpoints don't all have to map to a single entry point into a system. These can map to multiple systems, but we're using this consistent API endpoint, and hopefully we're giving the developer a consistent API to work with. But to me, this is not ideal, because when you go from one REST API to another, everyone's implementation is different, at least in my experience. And this is very, very, I've never seen really two APIs implemented the same, regardless of how much we want to say that there are documented ways of REST best practices. So what we're seeing an explosion of within AWS and also within the GraphQL ecosystem is this idea of using GraphQL as an API gateway. This solves a lot of the problems around API inconsistency, but it also brings to the table all of the positive things that you get out of GraphQL out of the box, like type checking, real-time updates for any mutation, query efficiency, API documentation, etc. So let's look at how we could maybe take advantage of this with third-party APIs. So we want to think about how can we use third-party APIs and build an API gateway using GraphQL? Well, there's a really interesting company out there that's called OneGraph. And OneGraph essentially has done this, and they've made this available for anyone to use. So some of the services that they support, and this is just a subset, I think there are maybe around 100 services or so, 50 to 100 at this point. Let's say we want to have a way to query Stripe, we want to query GitHub, we want to query Gmail, Twilio, Twitter, and YouTube. And we want to have a really easy way to understand how to do this. Now, for me in the past, what I would have done, I would have gone to Stripe's documentation and I would have dug around in the docs, and I would have gotten really frustrated, and I wouldn't have even understood exactly what's going on. And then I might go to YouTube, and it might take me a few minutes or a few hours to get up and running, understanding how to make a simple query. OneGraph is actually really simple because they've put everything in front of a GraphQL API, and within minutes, I was able to start querying for data from multiple different data sources. And you can even map different graphs together. So in this example that I'm showing here, we're querying for Stripe data, and then we're also querying from a child Salesforce data. So you can kind of put multiple queries together into a single query. But I think the real power here is how consistent this API is. I don't really care about the implementation details or anything like that. When I go into this editor, I can actually look around and see all of the data that's there and all of the different ways that we can query it. And I'm going to demonstrate this once we deploy our own API in just a moment. Another really super interesting use case for me that I've started to see is this idea of querying blockchain and Ethereum data with GraphQL. So a big thing in the Ethereum ecosystem is this idea of decentralized applications, or as they call them, dApps. And if you go to the Ethereum documentation, you can see that there are thousands of these APIs that are out there. There are thousands of these Ethereum deployments, and people are doing all kinds of stuff. Everything from lending and borrowing to token swaps, investments, crowdfunding, and all types of different use cases. One of the really interesting ones is Compound. And Compound is a money market protocol built on Ethereum. And it basically allows any person or machine to easily earn interest by lending their cryptocurrency assets. So if I went there and I was like, okay, I want to make some money off of my Bitcoin, or I want to make money off of something else, I could just leave that there. And then over time, I make money. And it's becoming really popular. And basically, the lent assets can then be used as collateral to borrow other assets locked in that protocol. So it's a really powerful and popular, application of Ethereum. But let's say I wanted to use this service or this API. I would, of course, as I would with any typical API, I would have to go into that API documentation and understand it. But let's say I wanted to build one of these myself. As it stands, you can't really build great applications directly on top of blockchains. The problem is that you need to have data indexed and organized for efficient retrieval. Traditionally, that's kind of the work that databases do in the centralized tech stack. But in Ethereum, the indexing stack was missing, and it was kind of missing in what they call this Web3 stack. So in comes this company called The Graph, which is a super interesting company that's doing some really cool stuff around GraphQL. And the Graph is a indexing protocol for querying networks like Ethereum and IPFS. Anyone can build and publish open graphs open APIs called subgraphs, making the data easily accessible. Now, before the Graph, teams had to develop and operate proprietary indexing servers. And this required significant engineering and hardware resources, and actually broke the important security properties required for decentralization, because the idea behind decentralization is not to have a single place where everything is located, right? And that's what they were basically having to do. They were having to build these servers that index their Ethereum applications and then make those endpoints public. And it's really interesting because the Graph kind of solves this problem by offering this consistent indexing protocol, and it does it using GraphQL. Anyone can build and publish open APIs called subgraphs, making data easily accessible and making someone like me, making it really easy for someone like me to query this data, because I'm a GraphQL developer. I can pretty much go in and query data from any GraphQL API, right? I don't really care who built it. If it's GraphQL, I understand GraphQL, I can do it. One of the really cool applications that I've seen is this website called Foundation. And if you've heard of MFTs, that's like the big thing people are talking about, right? This month or the last couple of months. Foundation is built on top of the Graph, along with a few other really big financial applications. So that's kind of how GraphQL is being used in the Ethereum space. What I want to talk about today, though, is the cloud space. Now, as a developer, when I first started learning AWS, I opened up the AWS Management Console, and I immediately became overwhelmed. When I joined AWS, we didn't even have this many services. But let's say you join and start looking at AWS now, you're going to see how that there are over 200 services at this point. So what I want to do is try to make this, the idea of working with the cloud, a little easier by applying GraphQL to the issue of consuming and creating GraphQL APIs, or creating APIs to the cloud, I would say. So let's look at how we might take advantage of GraphQL to leverage an API gateway to the cloud. In this example, we have a few different types like we have in the past. We have a product type and we have a label type. What we basically want to do, though, is we want to expose this data in a GraphQL API, and we want to take advantage of a few different cloud services like databases. And again, your queries do not have to map to actual databases. As long as they're a data source, that's all that matters. So for instance, let's say we want to go ahead and execute a couple of queries. And what we want to do is we want to call a list products query, and we want to call DynamoDB from this query. We don't really care as a consumer of this API where this data is coming from, and we don't even know where it's coming from, right? We're just expecting this array of products to come back, and we know if we execute this query, we're going to get this array back. And then we might want to hit Elasticsearch, right? Because we might have a more complex querying ability than what DynamoDB offers needed for this query. And we want to just call a query, and we don't, again, care where it comes from. We just want to be able to ask for the data that we want, and we want it to be returned in a consistent manner. And then we might say, okay, we also want to throw in some machine learning here. So we might want to say, okay, I want to be able to pass in an S3 image. And from that, I want to be able to go ahead and run some type of machine learning program over this image and give me some data back on that. We can do that as well directly from this GraphQL API. And me as a consumer, I can come in and take a look and see a very good idea of what's going on here without really needing to know anything about the underlying infrastructure. But let's take a look at a little bit more of a complicated use case. Let's say we have some relationships, relational data that we're working with. We want to go ahead and query, and we want to first get the data for the user because the account type has a dependency upon multiple types of data. Once we query for the user has returned our data, and then we now need the order information. The order information also depends on the products. So for the array of orders to come back for the user, we also need to return the array of products for each order. So in a single operation, we're going to get that data back, and we're going to return it, and we're going to get this account object back. Now, as a consumer of the API, this is very, very simple. As someone on the back end can see, there's a lot going on here, but it's really simple to kind of build this in and give it to the user in a really consumable, really easy to consume way. And this is a general idea, but I think that what I'm going to talk about in a second is going to make a little bit more sense around why it's valuable to do this in the context of a cloud application. So let's now take another look, though. One of the things that I talked about before, whoops, I need to go ahead and jump forward here. One of the things I talked about before was the ability to just ask for the data that you want. So again, taking the same ideas that we've typically been using in the GraphQL space, we can apply them here. We have a few different operations that are happening. We're going to be calling an onload function when our app loads. We're going to be saying we want to get products, we want to get the user, we want to get the wish list, and we want to get the on sale items. Now, in a single operation, we can go ahead and fetch all of this data. It all comes back. But let's say we're now building out a mobile interface to our API. We want to now have a smaller selection set, right? Because we're more cognizant of the user's latency on their device, because maybe we know that desktop apps are a lot faster than mobile apps. So we're going to now present a completely separate query, but we don't have to write any different code. We still have this onload function, and we're still calling a few different queries. But here we're only returning a smaller selection set for each item. So for the list products, we don't need certain values. For the user and the on sale, we don't need certain values. But we don't have to write any more code. This just works. But now let's talk about building cloud APIs and kind of adding the GraphQL part to this and how this works and why it's valuable. Well, when you're building a API with GraphQL in the cloud, there's three main things to take into consideration, in my opinion. First of all, there's the execution environment. Second of all, there's the permissions. And then there's the actual SDKs for interacting with the different services. So let's first talk about the execution environment. There are two main approaches that you can typically take here. There's this idea of serverful, and then there's the idea of serverless. Now, you may have heard of serverless, and you might not have heard of serverful, but you can think of serverful as the opposite of serverless. So serverful means you're actually operating and maintaining your own server. So let's first take a look at the benefits of serverful. When you're building and taking advantage of controlling your entire API, you're not using a managed service like serverless functions or anything like that. You have complete control over all aspects of the server environment. So you're not really limited to anything other than the limitations of the operating system that your server is running on. So I think that's really the main benefit of using a serverful environment. And possibly if you kind of are also having a really good understanding around how much usage you're getting over a long period of time, you might be able to cut the cost a little bit versus a serverless environment. But I think the capability of serverless to scale up and down at the end of the day typically saves companies money. Some of the downsides, though, with a serverful environment, You have all the typical security implications that you might have to typically consider in a server environment, like mitigating DDoS attacks. But you also have to take into consideration GraphQL specific concerns like malicious queries, which can be mitigated with things like recursion depth limiting or having a mechanism in place to calculate a complexity score for queries coming into the system. But if you're not a sophisticated or experienced GraphQL, someone in the GraphQL space, you might not understand or have an idea of how to do this properly. So it takes a little bit more work. You also have to implement subscriptions yourself. Like I mentioned, subscriptions are part of the specification, but it's on you as someone building an API to implement these and implement them properly and implement them at scale. You also have to, of course, worry about all the typical things that you have to do in a server environment, like scalability and resiliency. You have to deal with stuff like caching and security. And when I say security, in addition to the things I already mentioned, you also have to take into consideration things like authentication, authorization, fine-grained access control, etc. So my personal preference is building GraphQL APIs in a serverless environment, but I'm also someone that really likes the idea of serverless computing. So this is kind of like just my take on it. But both of these ways are kind of valid ways, in my opinion, serverful or serverless. Now, there's two main options for building a serverless GraphQL API on AWS. One is AWS AppSync, and this is a managed GraphQL service, and this is what I'm going to be using in my demo. And the other is Amazon API Gateway with AWS Lambda. And this is a way to basically run a monolithic GraphQL server in a Lambda function. There are some trade-offs here, though, because you're running all of your code in a single function. It gets in the way with things like logging and monitoring and stuff like that. But also baking in subscriptions is a little tougher than when you take advantage of something like AWS AppSync. And AWS AppSync is just a managed GraphQL API service. So what are some of the benefits to building in a serverless environment? Well, they're almost the opposite of the trade-offs that I just talked about in a serverful environment. So all of the things that are benefits are going to be trade-offs, and all the things that were trade-offs there are going to be benefits here. So benefits for building a GraphQL API gateway in a serverless environment are going to be things like built-in security, authentication, authorization in the context of AppSync, subscriptions that work at scale for tens of millions of connected devices for a single endpoint. That's AppSync. That's kind of built in. You also have the typical scalability and resiliency, no server management, pay-per-compute stuff that you get from a serverless architecture anyway. Less code, right? So you don't have to maintain as much code because you're dealing with managed code. And then finally, caching, which is something that's built into the AppSync service. Now, what are some of the downsides of working with a serverless GraphQL API? Well, you're limited by the API surface provided by the service. Where in a serverful environment, you have full control over the API service and what's there. When you're dealing with a managed service, you're, of course, limited by what that API service provides. So if you're not happy with the things that AppSync opens up for you, the escape hatches that are there, you're pretty much stuck there, right? So you're limited by what's there. So if there's a mismatch between what you're trying to build versus what the service offers, then it might be a time to consider building it yourself from scratch. You also have to consider cost at high scale over extended period of time. So if you know for sure that your app is going to be getting 10,000 requests per second over the course of 2 months, then building in a serverless environment is going to be more expensive because really where you get the power from serverless is like scaling up and down when necessary. If you have consistency over time, then it might be a better choice to build this in a serverful environment. And then long-running tasks. So if you need some type of really long-running task, anything longer than 15 minutes, a serverless environment usually isn't the best choice. One of the other things, though, you have to take into consideration that you just need to have a general understanding of when you're working with the cloud is permissions. And once I kind of understood permissions, it kind of opened up the entire floodgates of what is possible. Because when I thought about permissions in the past, it was really confusing when I first heard about some of the ideas around things like identity and access management. But once I understood exactly what's going on and how kind of simple it was, it kind of opened the doors for me to understand how to actually do stuff in the context of what I'm about to talk about. So let's talk about a typical application where we have a Lambda function and we want it to talk to maybe a database, in this case, a DynamoDB table. So I want to execute this function and I want to call the DynamoDB table to either query some data or maybe create something in the database. Now, if I don't set up a permission here, then this is going to be rejected. What I basically need to do is, because by default, Lambda is going to not, or all the services are going to be denied by default. You basically have to say, okay, I want this service to be able to talk to this service. And typically you can go in and just create some type of policy, and you can say, hey, I want this Lambda function to be able to talk to this DynamoDB table. And then anytime you call that function, then you don't have to worry about anything. Everything is going to be good. The Lambda function now has permission, and that's kind of the key there. Like anything that you need to talk to each other, you need to set up your permissions. Once you have your permissions set up, then you need to start considering how are you going to interact with these different services. And typically, you're just going to be dealing with the AWS SDK. So there's AWS SDKs for everything from Node.js to Go to Python and Ruby. And we'll take a look at how it looks like to interact with something like DynamoDB. You typically need to create a DynamoDB table, give it permissions, and then you want to say, I want to call DynamoDB document client.send, and then you set up some command. And that command just maps to the DynamoDB operations. So get, delete, list, query, things like that. Or scan, I guess, would be the command for DynamoDB. And then for working with services that do not have to be created, you can do the same thing though. So all I need to do to work with a machine learning service, for example, like recognition, I don't need to actually create an instance of recognition. Once I give my Lambda function permission to talk to recognition, then I can make as many calls as I would like to the service. And doing so is fairly simple. So let's say I want to build out a machine learning application and I want recognition to be able to detect what is in the picture. All I need to do is write these 4 lines of code. I'm going to be creating a new instance of the recognition client, and then I'm going to call client.send, passing in the parameters that I need. In this case, I'm just setting where the image is, and then the data coming back is going to be in JSON format. So hopefully the general idea I'm kind of giving now will come across better. Also, when I create a little bit of code, which we're going to look at now in the deployment. There are a couple of different deployment options. The one I'm going to be working with today is AWS CDK. You can also deploy using anything from the AWS console itself to all of these infrastructure as code frameworks. Infrastructure as code is a really nice way to be able to work with the cloud, and that's the way that I'm going to be working with today. The team that I work on, we work on the AWS Amplify CLI, which is a really other great option as well. But I'm going to be using AWS CDK today. So let's go ahead and take a look at a demo. What I want to do is I'm inside of a CDK project, and I want to go ahead and build out a cloud API gateway using some of the things that I talked about today. Okay. So when you create a new CDK project, you can do so running CDK init, and then you set the language as something like TypeScript. After you've done that, you'll be given this shell project that looks something like this. And the main thing that we're going to be working in is the cloud API stack. So in the lib folder, you're going to have your stack. And then here, where I have this comment, where we have our infrastructure as code, this is where that's going to live. And to work with the different services, you just have to npm install them. So what I want to do here is I want to create a cloud API that allows us to query from DynamoDB, but also has a way for us to call an external HTTP endpoint, which is going to be the Unsplash API. So all we do is we import and install AppSync, DynamoDB, and Lambda, and we're ready to go ahead and start writing some code. So the first thing that I'm going to do is I'm going to go ahead and create a GraphQL API. And we're going to say new AppSync GraphQL API, and then we here just give it a name. API test. We define the schema that we want it to go in. So we have schema.graphql, and then we set the API key as the authorization type, making it public. Next, we'll go to GraphQL. We'll create a folder called schema.graphql. And we're going to go ahead and create our schema. Now, let me zoom out a little bit. The schema has an image type for querying our Unsplash images. We have a URL type, which is a field on our image type. We have a post type, which is going to be for creating items in DynamoDB. So we're going to have like a blogging backend. And then we have our queries and mutations, which I think are the most important parts here. This kind of tells you how we're going to be interacting with our backend. We have a way to list an array of posts, query for a list of an array of posts. We have a way to search images by passing in an argument that is a string, returning an array of images. We have a way to create a post. And then we also want to say, hey, why not just throw in a GraphQL subscription as well? We want to have a real-time update. And to implement a real-time update, we only need these 4 lines of code here, where we're basically saying we want to subscribe to this array of mutations. In this case, we're only worried about creating a post. And then whenever a post is created, we can subscribe to that. So that's our schema is done. We can continue writing some code. The next thing we want to do is we want to create a Lambda function. In the Lambda function, we want to do something like, let's go ahead and set the runtime to Node.js 14.x. And we're going to just set the code location, which is going to be in this Lambda functions folder right here. And we're doing a couple things like setting our memory size. But these 5 lines of code or 6 lines of code here give us a Lambda function. And when we deploy this, we're going to have a way to write our business logic that interacts between our GraphQL API and our data sources. And then I want to set a data source on my GraphQL API. So I've created this Lambda function. I've created this API. I want to now add a data source. And I'm going to give it an ID. And then I need to just give it a reference to that Lambda function. So now we can start mapping GraphQL operations from our API into our Lambda. So now we want to add our resolvers. So we've created our schema. We've defined our queries and mutations. Now we need a way to resolve those fields. So when we call list posts, we want to map this operation into that Lambda function. So in the event, we're going to be getting this information that is passed into this event, if there is any. And it's going to execute that function. So for list posts, for create posts, and for search images, these are all going to be mapped into that Lambda function. And then finally, we want to go ahead and create our DynamoDB table, which is our data, our actual database. Here, we're going to go ahead and say we want to create a table called post table, and we're going to give it a partition key of ID, meaning that the unique identifier needs to be an ID, and the type needs to be a string. So this creates a DynamoDB table. So we've created our API, we've created our DynamoDB table, we've created our Lambda function. And I mentioned earlier IAM access. So we just now need to say, okay, our Lambda function needs to have access to our DynamoDB table. So to do that, I can just write a single line of code here. I'm going to say I want the post table to grant access to the function, meaning that I can now invoke that function and call the DynamoDB table from there, and we're good to go. And next, to wrap things up, I want to go ahead and give a couple of environment variables. One for the post table, meaning I can now reference process.env.posttable, and then process.env, our unsplash key. So the unsplash key is our how we're going to be interacting with our unsplash API. So I can go to developers and go ahead and get my unsplash API key. And then I'm going to paste it right here. Okay, so we're done now with our infrastructure as code. So we've actually built out an entire cloud AppSync GraphQL API, really in about 50 lines of code minus the comments and white space. The only thing we need to do now is create our Lambda function code. And I know we only have about 3 minutes or so remaining, so I might go over about a couple of minutes, but we should be out of here. I should be done with this in about 5 minutes. So we can think of the different things that we need to do within the context of our Lambda function execution environment, mapping directly to our operations here. So we need to have a list post operation, which means we need to have a function for calling list posts. We need to have a function for calling search images, and we need to have a way to call create posts as well. So I've basically created a main entry point within our Lambda function called main.ts. That's going to be our handler. And from here, we're going to start interacting with different functions to call our different data sources. So the first thing that I'm going to do is go ahead and create our code for our main entry point. Our main entry point is going to have three functions that we're going to work with: one for creating a post, one for listing posts, and one for searching images. If we look at the handler function, we see that we have three main options here, and we're switching on the event field name. And the field name is just whatever field name that is coming through. So the field name would be something like create posts, list posts, or search images. And when that happens, we're going to say, okay, if create post comes through, we want to call the create post function, passing in the event arguments post. If list posts happens, we want to call list posts. And if search images comes through, we want to call search images, passing in the query. And that's really about it. And now we just need to create the code for those three functions. Create post is a fairly simple function where we're going to be calling dynamodb.putItem, passing in the params, which in this case are going to be the post table, environment table name, and the post itself, which is going to contain the ID, the title, and the content of the post. So this is going to be interacting with DynamoDB. Then we have our list posts. List posts is a very simple query where we're just calling a .scan operation, and the only value that we need there is the environment variable for the post table. And then finally, for our search, we're going to be importing Axios to make our HTTP request. And then finally, we need to go ahead and set our API key here and our query here. And then what we're basically doing is we're creating this query called, or with the value of our api.unsplash.com/certs, blah, blah, blah. We're just setting our query that's coming in as an argument here, and our environment variable is the API key. And then we just call axios.get, and then we're good to go. So that's basically it. We should be able to go ahead and test this thing out. So what I can do to test it out, I can say cdk diff. I can get a good idea around what will be deployed if we decided to deploy this. When we run cdk diff, we see that we have a DynamoDB table. We have a Lambda function that would have been created. We have our AppSync GraphQL API. We have some of those IAM rules, which are the permissions that I was talking about before. We have a bunch of stuff, right? So we can deploy this by first saying npm run build. This is going to go ahead and build our TypeScript into JavaScript. Then we can say cdk deploy. And here we can just choose yes. And this is going to go ahead and deploy our backend. Now, to kind of make things fast, I'm going to go ahead and show you this deployment that we already have. So I'm going to go to US East 1. Oh, it looks like I need to sign in. I can just search for AppSync. And we're going to go ahead and take a look at this same API that I deployed a few minutes ago. We go into the schema, we're going to see that we have we have that schema that we created locally where we have the image type, we have the create post mutation, and then we have the list posts and search images query. If I go now to the query editor, I can start testing this thing out, and we can look at some of the stuff I was talking about, like GraphQL schema introspection and things like that. So the first thing I might want to do is say list posts. Then I might also want to create a mutation, creating a post. So for creating a post, we're going to pass in an ID, title, and a content field. And then I can return whatever fields I want. And there we see our data come back. And if we want to query for this, we can say list posts. We have 2 items that come back, including hello from SINFO. And let's say we don't want to return all of the data. We might want to only return just the title. Because we're using GraphQL, of course, we can return whatever we want. And then finally, we want to test out a way to query our HTTP API, which is the Unsplash API. So let's go ahead and say search images. Query is going to be something like, I don't know, French bulldogs. And then here, we don't really know off the top of my head. I can't really think what comes back from that. So let's go ahead and use the schema introspection to do that. There's 2 ways we can do that. We can actually go here into the docs and we can say, oh, we have a query and we have search images and it's going to bring back this image type with the width, height, description, and so on and so forth. We can also go here on the left and go ahead and say, okay.
Nader, I'm so sorry, but we're really running out of time here. The talk is being really good, and I'm hoping that you can please continue this this exhibition in the Q&A session, because
got it. Yeah. This is it. I'm pretty much done. I was under the impression that we had maybe 5 or 10 more minutes. After.
I didn't mean to cut you off, but if you just
you're good.
If you just want to do some conclusion or some concluding thoughts.
So, right. Yeah, that's it. That's the end of the demo. So yeah, thank you for checking out this talk. If you want to learn more, check out the AWS mobile blog, aws.amazon.com/blog/mobile, the Amplify docs. And then there's a good blog post around talking about GraphQL if you're interested in just learning about that, the GraphQL core features, architecture, pros and cons. And yeah, that's it. Thank you for having me. And I enjoyed giving this talk, and I hope you learned a little something.